Hi, everybody. Thank you for coming today. Sorry, I'm going to be hiding behind all my gear here, so I can't be out amongst you this particular time, so hopefully that's not too big of a problem. But as Sasha mentioned, my name is Dave. I'm here in San Francisco because I'm teaching some classes for New Circle this week. Generally, I'm based out of Denver. But I'm here today to talk to you about Android accessory development. So we're going to talk about Bluetooth, but we're also going to talk about USB. We're going to talk about Bluetooth LE, Bluetooth Classic, and all kinds of different stuff. And I've got a ton of demos to show you, and I just hope we get through it all because there's so much stuff. So just a couple things about myself. I said my name is Dave. I work in Denver for Double Encore. If you're familiar with them at all, we're an app development shop. We also do some embedded Android client work. In addition to that, as I mentioned, I'm an instructor for New Circle. I teach a number of classes there, including Android internals. And I also am the author of Android recipes from Apress. So if you want to be pleasant and help feed my family, please check it out. We actually just released the 3rd edition last week. So there's a brand new edition out that goes all the way through KitKat APIs. So if you're interested in learning some more about Android development, check it out. Okay? All right, so what are we going to talk about here? So these are the topics that I'm really going to look at. We're going to look at Bluetooth Classic, and specifically we're going to look at RFCOMM. So if you're not familiar with what that is, we're going to talk a little bit about what that really means from an accessory perspective. And then we're going to talk about Bluetooth LE a little bit. And that really splits out into 2 different categories. We call Bluetooth LE, we're going to look at it from the GATT perspective, which is connected Bluetooth devices. And then we're going to look at these things that we're calling beacons, which are Bluetooth LE devices that don't really accept connections and what that kind of means. And then we're going to dive into some of the USB stuff, and I'm going to talk about Google's USB API called Open Accessory that you can use to communicate with an accessory to a phone or tablet. And we'll also talk about the USB host APIs that you can use to write applications to communicate with other commercial USB devices. Okay? All right, so let's start with Bluetooth and work our way down. So just a little bit of background on Bluetooth Classic. Now, Bluetooth Classic is a relatively new term. It's essentially what we refer to as Bluetooth everything before 4.0. Okay, so now that we have Bluetooth LE or Bluetooth Smart, everything that doesn't fit in that category, we've decided to call Bluetooth Classic. Okay? So just some basic background about how all this stuff works. So in Bluetooth Classic, we have some concepts of things like device discovery. So device discovery is the process of 2 devices finding each other in order to make a connection. And in the Bluetooth Classic paradigm, this is actually quite different from Bluetooth LE, so I want to kind of focus on it. But device discovery in Bluetooth Classic is very centric to the scanning device. So in case of Bluetooth Classic, devices that are out in the world to be connected are known as discoverable, and they're actually just dumb listening devices. And the device, for instance, in the examples that I have, like the Android device, is out scanning, actively pushing packets out to the world to find these new devices. And that's specific to Bluetooth Classic because it turns out Bluetooth LE actually does it in reverse, but we'll talk about that a little bit later. In addition to that, we have this concept of pairing or bonding. Most people have probably heard of pairing. Not as many people have probably heard of bonding. They're kind of the same thing, but not really. When you're looking at the Android APIs specifically, they use the term bonded more than they use pairing. In general, a bonded device or bonded devices are 2 devices that have gone through the pairing process. So that's the sort of the difference between those 2. So when you hear that you're pairing 2 Bluetooth devices, that's simply a process you go through to enter in a secure PIN or some other connection mechanism to achieve a bond between those 2. Once those devices are bonded together, they can more easily connect together later on. You don't have to go through that same process over and over again. Okay? Yes, question?
That's a good explanation. How does tethering differ from what you described?
Tethering?
Yes.
It's completely outside the scope. I mean, tethering is as a higher level distinction of being outside any connection mechanism and is more about connecting some device or either wired or wirelessly for the purposes of like a network connection or something like that. So it's not quite at the same layer. Good question, though. Okay, one thing that I do want to focus on, though, is that there was a change in the Bluetooth spec in Bluetooth 2.1 where they added the ability to do something called simple secure pairing. Now, those of you who have basic Bluetooth devices, maybe a headset or you have Bluetooth in your car, you're probably familiar with the basic pairing mechanism, which is you connect to the device, there's some 4-digit PIN that you have to enter in on the screen, and then once you get that right, hoping the device doesn't time out before you get it entered in, you're going to have this connection and you can now start communicating between the two. Simple secure pairing sort of eliminates that piece and allows devices that support it the ability to pair and bond together without user intervention. Okay, this is very helpful for embedded devices where we don't necessarily have a display that we can either show a PIN code or type anything in. Okay? So, and that has some ramifications for what they added to the Android APIs. So we'll talk about that. The Bluetooth in general, both in Classic and LE, has this concept of protocols and profiles. This is really just how the stack is built. So the protocols are typically the middleware layer between the hardware and the link, and what we would call the abstracted profiles, which are more of the functional piece that that device represents. So a Bluetooth profile would be something you're familiar with, like a hands-free profile or a wireless media profile or A2DP, which is audio streaming to a speaker, or in the case of what we're going to look at tonight, a serial port profile. So these are functions that you actually interact with as an end user, and the protocols are typically just the pieces underneath that to be the glue between that and the link in the stack. Okay? So in the case of what we're going to talk about today, RFCOMM is really the protocol, and then the serial port profile is what sits on top of that in the examples that we're going to look at. Okay, and then kind of to finish that out, Bluetooth devices expose their capabilities to scanning devices via these things called services. Really, a service is just a logical definition of something you can connect to that is referenced by a unique identifier or UUID. Okay. So in the case of Android, those of you who have played around with the APIs a little bit, you may have landed on this part of the documentation before. This specific method, this create RFCOMM socket to service record, is designed to allow you to connect to an external Bluetooth device, open a channel, and start streaming data. But it passes in this unique identifier value, and the question is, well, what is that? You know, what do I put in here to get access to the service on the other device that I'm interested in? In the case of communication between two Android devices, this is an easy question to answer because, for instance, if you look at the Bluetooth chat sample that they provide, one device is implementing the service itself, and so you define what that UUID is. So you know what it is over here, so you just put it in your code over here, and you can make that connection. But in cases of an embedded device, like the one I have here in my hand, what is the UUID that I use to connect to this board? Well, what they added to the documentation shortly thereafter was this little note down here that basically says, hint, if you're connecting to a Bluetooth serial board, maybe you should try this well-known SBP UUID, and puts it out there in front. First time I read that, I'm like, well, what the hell does that mean? Well-known, I didn't know what it meant. But there's an interesting way about where that comes about. So the way that Bluetooth services are identified using these UUIDs is following this kind of pattern. Okay? So a UUID is always a 128-bit value. That's just by definition what it is. But in terms of the Bluetooth specification, there are a number of service UUIDs that are defined specifically by the Bluetooth SIG for specific reasons. So the serial port profile has an ID. I have them listed there. The RFCOMM protocol has an ID. And all of these are actually 16-bit values. But the way that they get translated into a full UUID is by taking this hard-coded base value that's true for every Bluetooth device ever. Bluetooth LE, Bluetooth Classic, all of them. And then they simply apply the 16-bit value in the initial field of the UUID. Okay? Now this also means that you can, if you're writing your own firmware or some other embedded Bluetooth device, you can create any service you'd like that has nothing to do with the Bluetooth spec. And you just identify it by your own unique identifier that has nothing to do with this format. But in the case of the standard ones, like what we're interested in is the serial port profile. That's what I want to connect to so I can start streaming data to my board. Well, if we take a look and we see that serial port profile's value is 1101, and then the rest of it is that giant hard-coded value for all Bluetooth, we add them together and we get the same number that we had here before. Okay? So it was well known to people who understood the Bluetooth spec, even if it was nobody else. Okay. So from an Android perspective, I won't dive too deeply into the code because I have an example to show you instead, but just some of the basic pieces that you would expect to see in the Android APIs for this. You know, if we're going to use an RFCOMM connection to communicate between an Android device and some embedded board or some embedded chip, First, we have to be able to discover those two devices. They have to be able to find each other. So the process of discovery in the Android framework is started on the Bluetooth adapter. So there's a method we call start discovery, and this is an asynchronous process that as it goes through, searching the world around it, it will call back into the application, in this case using broadcasts, every time it finds a new device that is discovered. And then at that point, our application can react to that, figure out if it's the device we were really interested in, and then try to connect to it or move on. Okay? At some point in the future, we may have already bonded to the device. It may already be active, and we don't need to discover it again. So there's also the opportunity to call get remote device to get a list, well, you can get a list of devices from the adapter and then call get remote device to get access to a specific instance of a device you've already bonded to. So you don't have to go through this process again. The discovery process does take some time, and it's also high power because it's turning on a radio and spewing a bunch of stuff out to the world. So we only want to do this when we actually have to. Okay? Then we have these methods for creating socket connections. And notice there's create RFCOMM socket and create insecure RFCOMM socket. The difference between those two goes back to that simple secure pairing idea. So create RFCOMM socket was the first version of this method that we got that allowed us to connect to a device, but it used the old prior to Bluetooth 2.1 standard pairing mechanism. So if the devices weren't already paired and you hadn't manually gone through that process somehow, this would usually fail. So you had to somehow add that layer into your application. With insecure RFCOMM sockets, we can create one of those and attempt to connect to that same device. If that device supports the Bluetooth 2.1 spec, I can pair to that device without any user intervention at all. Okay? So that's the difference between those two methods there. Once we have an active socket to our device, we can simply open or connect to that socket and then get a raw input and output stream from that socket. Okay, so now I've got an input stream, an output stream, and I can start shoveling whatever data I'd like back and forth. What that data is, specific to my application. There's no additional protocol or overhead I have to do at that point. It's just a raw open channel between me and my remote device. Yes?
So it sounds like these are all kind of client-side sockets. There's no server socket involved.
So I kind of skipped over it, but that section in the middle there sort of points to that you can also on an Android device set up a listen socket, and then by calling accept right after that blocks waiting for an incoming connection. So yes, in the case of RFCOMM, you can do either. This example was very client-based though.
You have to match.
Sure, so how do they connect together when there's no when there's no direct address known? Now, you may know the address because if you know it ahead of time, it's a MAC address instead of an IP address. But even still, in those cases, device discovery is what that's for. So during the discovery process is when you would find the other device and attempt to connect to that existing socket. If you want more information on a good way to do that, the Bluetooth chat sample in the SDK does exactly that. Both devices set up a server, and then they attempt to connect, and whichever one wins, that's how that direction goes. Okay, good question. All right. So beyond that, we have this idea of Bluetooth LE. So Bluetooth LE was added to the Android framework in 4.3. And so it's really only been around for a couple of months. 4.3 was released in July. So what this now provides is additional APIs that allow us to connect to Bluetooth LE devices using what's known as the GATT profile. So any device that implements or refers to itself as Bluetooth Smart or Bluetooth LE, and it's not a beacon, that device implements what's known as a GATT server. GATT stands for General Attribute Profile. It just runs on top of the attribute protocol. But these devices are basically just simple key value data. A GATT server device really just represents its memory as a key value table of information known as characteristics. And these characteristics are grouped together into services, and then these services are grouped together into one or more profiles. And the profiles are what you see published for things like the Find Me profile, the Proximity profile, the Health Thermometer profile. Each of these is a collection of services and characteristics, which is just data you can read and write discretely. Okay, yes?
So what is the question to which profile is the answer? What are profiles for? How do they help me as a developer?
it's really just an abstraction, right? It's a documented definition of a set of services and characteristics that a device could expect to have. So for instance, if a device claims that it implements the proximity profile, you know that because it claims it's implementing that profile, which is spec'd out by the Bluetooth SIG, that profile has these services and those services have these characteristics. So without having to have any additional documentation, you know how to talk to that device.
Is it fair to say it's like a Java interface?
Sure, yeah, it's an interface specification. That's exactly what it is. Good question. Okay, so then kind of beyond that, I mentioned this idea that Bluetooth LE deals with device discovery very differently from classic Bluetooth in the fact that it's exact opposite. So in Bluetooth LE, the devices themselves, the server devices, don't listen when they're in a discoverable mode. Instead, they're constantly advertising. Okay? This helps us get to this concept of beacons a little bit later. But the devices that are out with data on them are simply advertising on some regular interval. So a scan, in this case, is not a transmission. Instead, it's just listening for incoming advertisements. That's one of the reasons why scans in Bluetooth LE are so much lower power, because the beacon devices themselves are doing this on a schedule instead of continuously. And on the other side, the scanning device isn't transmitting at all. It's just listening. Okay. And then, so there's a number of what you would consider device roles when we talk about Bluetooth LE. Now, there's 4 major roles. There's what we call the central role and the peripheral role. Those are connected roles. And then the observer and the broadcaster, those are kind of the paired roles of what we would think of as a beacon. Okay. So a broadcaster is a beacon and an observer is a device just looking at beacon information. Okay. Central role and observer, to date, are the only types of roles we can implement inside of an Android application. The APIs are not there to do the other things yet. There are hints that they will be there eventually, both in the way the API works and things that Google will tell you at conferences. But in general, today, all we can do is central role and observer. Okay? And those are the examples we'll look at. Okay. So this is just sort of a visualization of what I had just mentioned there. And this is sort of how the data gets collected inside of a Bluetooth LE device, right? So there will be one or more of these profiles. Each profile will have one or more services defined in it, either with a custom UUID, if it's not a specific profile that the Bluetooth SIG defines, or these assigned, what are called assigned numbers, which are really just those 16-bit UUIDs that Bluetooth SIG does define for its own services and characteristics, okay? And then underneath each service is going to be a group of characteristics. So a characteristic is really just it's a value with some properties. So I mean, you know, the service, for instance, the profile is the health thermometer, and the service is the actual thermometer data, and then the characteristics inside of that would be the temperature value, the temperature units, and you know, maybe some other configuration information, okay? So that's kind of how that would break down in a general case. Okay. And it's the same basic information about the device architecture. I won't go over that again. Okay, so from the API, oh, go ahead, question.
Can you define your own profile?
Absolutely. Now, getting those ratified is a different story, but the idea is that I can make any UUID I'd like to advertise a service and a characteristic. So if I want to make my own that has nothing to do with interoperability with other Bluetooth devices, it's just my own custom thing with my own custom application, go for it, absolutely. That's why that part to the spec exists.
Publish it to your clients.
Exactly. That's exactly. The profiles defined by the SIG they're really only for the purposes of interoperability. So that by simply calling something X, we all know what that means and we can all talk together. But if it's specific to you, define your own. Absolutely. Yes? Sure. Well, so one of the reasons is kind of what I described earlier about the difference in scanning procedures. But even beyond that, you'll notice that there's no such thing as a Bluetooth LE profile that has streaming data. Right? These are all key value packet-based communications. We don't open a stream for audio and start pushing data over Bluetooth LE. So it's simply conceptually the fact that there are smaller data packets that are transmitted in interval chunks rather than setting up streaming channels. Between that and the scanning, those are kind of the two biggest reasons. Yes?
The key value architecture?
I'm sorry, say again?
What's the key value architecture? Like JSON type of thing, or what is that?
No, I mean, it's really... Sure. The question was, what is the architecture of the key value data? I mean, it's really just a map in memory. You know, the IDs are just memory addresses to the values, so it's not that high level at all. It's the job of the Bluetooth stack on the device to simply expose those addresses as specific characteristics or services. And when we request packets come in that define those IDs, which they do so by that same address value, then it's the responsibility of the Bluetooth device to respond back with another packet that has the data in it. So it's packet level communication. It's not higher level in any type of definition that you would think of JSON or XML or any other data format that's structured. Does that make sense? Okay.
Sort of.
Okay.
Mostly.
Okay. Yeah.
So it sounds messy.
That's correct. You know, and actually another important distinction to make is that Bluetooth 4.0 and Bluetooth LE are not the same thing. Okay. The Bluetooth 4.0 spec is just the next version of the Bluetooth spec that includes BLE as a part of it. But all the other pieces in Bluetooth that we've continued to use that we now calling Bluetooth Classic are still active and well. You know, it's streaming audio to my car happens over Bluetooth Classic and will probably never be part of Bluetooth LE. It's just another piece to the whole puzzle. How difficult would it be to backport the Bluetooth LE APIs to Ice Cream Sandwich? Extremely. Specifically because, at least in that difference, you're talking about Bluetooth LE APIs were added into a version of Android that had a completely different Bluetooth stack than 4.0 did. The Bluetooth stack change actually happened in 4.2, the version just before it. And that drills down deeply into how the stack is implemented and how that works with the underlying hardware. So I wouldn't expect to do it anytime soon. Now, what the manufacturers have done prior to when Google came out with their own APIs in 4.3, they provided their own SDKs to do Bluetooth LE specifically on HTC devices or on Motorola devices. And they could do that because they were putting their own pieces in the Bluetooth stack when they built those system images, which is probably the more likely proposition in that case. Yeah, for sure. All right, let me keep rolling here, and we can do some more questions at the end because I want to make sure to get to the demos. Okay, so just a couple other pieces about the APIs. So when you're scanning for new devices, there's a different method for LE scans. It's not discover devices, it's start LE scan. Then once you have a reference to the device that it gets discovered, you're going to connect to that device with connect GATT. So it even has a separate connect method than traditional Bluetooth Classic. So, and remember, you're going to see the word GATT a lot in the APIs, and that's because it refers back to the GATT profile that Bluetooth LE is kind of based on. Okay? Then once we have this connection in place, we can start reading and writing these characteristic values by ID. So every characteristic has a UUID. We tell it, I want to read this characteristic, if it's the temperature value of a thermometer or whatever the case it is. Or I want to write something back. Maybe it's a configuration value. Characteristics also support notification. So I can tell the Bluetooth device that I'm interested in this characteristic, and while we're connected, when this value changes, you tell me. Okay? That goes back to that whole low power thing. I don't have to keep polling the device for new data. The notification tells me when that information occurs. Okay? And then all these processes, though, are asynchronous. So there's this Bluetooth GATT callback that basically you have to implement for all these different methods when these events occur. So I call read characteristic, but it doesn't come back to me until on characteristic read is fired. I call write characteristic. It's not done until on characteristic write has taken place. Okay? And that's actually very important because you very much want to wait for those characteristic callbacks before you move to the next event. Trying to queue these up, at least in the Android APIs, fails every time. Okay? It very much only works one at a time, and so your code will end up having this giant state machine in it where you say, do this, okay, done, do this, okay, done, and just kind of cycling through this. Unfortunately, I've tried to do it any faster than that, and the API just freaks out. Okay? So you very much have to involve those callbacks. Okay, so moving on to broadcasters, or what we would call beacons. So an LE broadcaster is really just a device that is transmitting data in its advertisement rather than accepting incoming connections. Okay, so a beacon device or a broadcaster, like the ones that I have here, and I've placed a couple around the room, These devices have a very simple Bluetooth stack because they don't support connections of any kind. They simply, on some regular schedule, send out an advertisement, and the only difference between that advertisement and what a connectable device sends is that it includes the data that it has in its advertisement. So rather than having to connect to the device to find some information on a characteristic, I just parse the advertisement and it's right there. Okay? So it's much faster, but at the same time, advertisements aren't exactly large packets. So that limit of what I can fit in there gets hit pretty quickly. You know, we're talking 27 bytes maybe. You know, there's not a lot of information there. But for a handful of sensor values, works great. So that also simplifies the Bluetooth stack on the embedded side. So it's become very popular just because embedded developers can write these devices without having to deal with a very complex Bluetooth stack on an embedded device that handles you know, connections and reconnecting and all those types of things that are in the rest of the Bluetooth spec. Okay? All right, so just kind of a basic about this. So there's a callback in the Android API is called onLEScan. And this callback is where you'll get this regularly whenever a new device is discovered. And in addition, there's this third parameter that when we're dealing with connected devices, we tend to ignore for the most part. But it's what Google calls the scan record. And what's in this is actually the advertisement data packet in raw format. Okay? Now, according to the Bluetooth spec, all this data packet really is a series of these advertisement data structures lumped together in an array. Okay? And each of these structures is quite simple. It just contains a length, a type, and some type of a payload. Okay? So you can kind of parse through this array pretty simply with beacon devices to get out all these specific elements. You know, whether it's a iBeacon made by some Cupertino fruit company or other beacons designed by other developers that have a different protocol to them. Okay? Then the types themselves, again, kind of like with services and characteristics, could really be anything, but there are a number of standard types that you will find defined inside Bluetooth assigned numbers. And most of the beacons that aren't made by Apple are going to use these standard Bluetooth IDs in one way or another. Okay? So you'll find things like there's an ID for a device name, IDs for service data, transmit power, you know, other things you would expect to find. And then based on the type value, that sort of defines how big the payload's going to be. So you can just kind of look at these pieces and parse them out in chunks with a pretty simple parser. And I've got one in the example as well. So in terms of beacons, the service data becomes the most important, because we may have interesting information like the device name that we can display, but the service data block is where that information is going to be. So, you know, if we want to stick a temperature value in our advertisement, it's going to be a service data block with the UUID of a thermometer and the value right after that. Okay? So that becomes sort of the most important in terms of beacons. All right, so then just a couple hands-on tips, if you will, from dealing with Bluetooth LE and Android. The first one I already mentioned, but I'll stress it again. Wait for those callbacks. If you're going to do anything with Bluetooth GATT, you're going to end up doing this in a very, even though it's an asynchronous API, a very one-shot synchronous fashion. So read, callback, write, callback, set characteristic, notify, callback. Otherwise, you'll confuse the Android APIs. Maybe that'll change in the future, but it still works that way, at least in KitKat. Okay? Make sure that if you're doing anything with the user interface, you're going to need to post the results you're getting onto the main thread. These callbacks come back on a thread pool. So everything that happens in onRead, onWrite, onChanged are on some random pool out of a thread, and you try to touch a view from that thread and you're going to have a very bad time. Okay? So you need to post those changes back to using a handler or whatever case you're familiar with to get that data onto the main thread before you update the UI. Okay? Notifications are kind of tricky, and this may change in future versions of the API, but at least today, the method for doing this in the API is set characteristic notification. And if you look at the documentation, you assume that by calling this method, it sets what we need to on the remote device. You would be wrong. It turns out that set characteristic notification just sets locally on the Android device inside of its internal GATT server database that this characteristic should have notifications turned on. But nobody told the device that that was the case. So generally, anytime, and you'll see that in the example code that I have posted, anytime you need to set notifications on a characteristic, you have to tell the local database using set notification and write that characteristic explicitly on the device. Okay? Android has this hard limit right now, and they don't tell you about it, that is you have to have a maximum of 4 simultaneous notifications active at any given time. So if you try to set notification on more than 4 characteristics, it'll just stop working. Okay? There's a lot of that in the Bluetooth API right now. It'll just stop working. Okay, and then the last piece is, unlike with Bluetooth Classic, which has really been a part of Android APIs for so long, we don't even really pay attention to whether or not devices have it anymore. Bluetooth LE is still relatively new. So if you're going to use this in an application, you're going to want to make sure that you're properly verifying that the devices that you're running on have support for this. Just because a device says on its spec sheet that it has Bluetooth 4.0 doesn't mean the manufacturer implemented the LE APIs. It just doesn't. So you have to check either using a manifest filter for Google Play or simply at runtime checking with Package Manager, does this device have this feature? Okay. All right, so just a little bit about the stack. Bluetooth devices will come in a number of different flavors. You'll typically find them in either a single mode or dual mode version now that we've come into Bluetooth 4.0. Bluetooth 4.0, the Bluetooth stack itself is different enough that many devices will only support one type or the other and not both. But the stack is common enough, as you can see here, that we get most of the way up before we start to diverge. And then like in our classic example, RFCOMM and serial port profile are different from our attribute and GATT, but everything underneath that, as far as the protocols and links, are actually the same. So many devices will be what's called dual mode and will support both of these, where others may only be one versus the other. Now, in terms of marketing terminology, this is how that kind of breaks down. So when you hear the term Bluetooth Classic applied to a device, that means that that device is single mode and only supports the Bluetooth stack, probably up to Bluetooth 2.1. Okay? If it's a Bluetooth Smart device, that means that it only supports Bluetooth 4.0, probably the BLE piece of that. Okay? Bluetooth Smart Ready means dual mode. Okay? So oftentimes, Android devices will be marketed as Bluetooth Smart Ready because they support classic Bluetooth and BLE on the same chip. Okay? So, something to keep in mind. Impress your friends at your next party with that one. Okay, so a little bit about the history of the APIs for Bluetooth. So inside of the Bluetooth, we've kind of had a long history of how this has evolved through Android. So we got the first APIs in Android 2.0. That's level 5. As I mentioned, that was a long time ago. Most of us don't even pay attention to devices that old or older anymore. And this was a very simple API at the time. It was RFCOMM only. It gave us enough to discover devices, connect to them using sockets, and transfer data. And that was about it. Okay? In Gingerbread, specifically the version 10 of Gingerbread, we got that insecure RFCOMM connection support. So after they revved it into the Bluetooth spec, they revved the APIs on Android to include that create insecure socket so that we could start connecting to embedded devices without having to do this manual pairing process. Okay? In 3.0, they added Bluetooth profiles, which we won't talk a lot about today because they're kind of outside the scope of dealing with accessories. But this is if you want information about connected commercial devices that support or implement a given profile. So if you want to figure out, is there a headset connected? Am I connected to my car right now? You know, health devices, do I have a Bluetooth heart rate monitor or something like that? The APIs associated with these are pretty thin. You know, really beyond determining that these devices are connected and maybe doing some basic introspection of them, there's not a whole lot there. So these were really more things they added for platform level support than to help developers out in any way. But those have kind of evolved over time, even all the way up to KitKat, where they added the hit over GATT or HOG-P profile and the message access profile. Okay? In Ice Cream Sandwich R1, I guess you could say, they added a public method for doing UUID searches. So this is actually a process that happens during device discovery anyway, where when I discover a Bluetooth device, part of that discovery process is it's going to go out and query that device for all the services that that device exposes and give me back a list of those as UUIDs. It did that all the time, even since Bluetooth 2.0, but it never exposed that functionality to developers. So I never had any way myself to figure out what the UUID was on a device I'd never touched before. There were some hacks using reflection, and I admit even I had done it. But now we don't have to do that anymore. So in 4.03, they added public APIs to allow you to do that service discovery. That's what SDP stands for. And get those UUIDs back so you could sort of interact with the device a little more explicitly if you didn't know exactly which UUIDs there were there. Okay. Then we, of course, talked about we got Bluetooth LE APIs in 4.3. And then recently in KitKat, we actually got an addition back to the classic Bluetooth stuff where if you're not using simple secure pairing, your device has to interact with a PIN code. You can pre-program into your code the PIN that it should automatically apply. Okay? So now, as part of that pairing process, you can say, well, I know this device has a PIN code, but I still don't want to bother the user with it. I can auto-apply that PIN as part of the process in my own code. There's APIs for that now. Okay? All right, so let's take a look at my first set of demos here. And if this is too easy or too hard to read, please let me know. All right, so I think what I'll do is show you the example first, and then we'll look at the code, because the examples are more fun. All right, so what I've got here is my little Nexus 7 and my fancy game controller that I created out of an Arduino and some additional shields. Okay. Now, we probably won't have time to look at the Arduino code. If you're curious about it, I can show it to you, because it's not that complex, but I want to make sure we get through everything else first. Okay, so what we're going to do is I've created just a very simple game that I have on my Android device, and I'm going to use my Bluetooth controller to play that game. So this is going to happen using the classic Bluetooth APIs using an RFCOMM connection. Okay, so I'm going to open a stream between this device and my tablet and start playing the game using my controller. Okay? So let me power up my controller first. We'll launch the app. Okay, so when I get this up, the first thing that I need to be able to do is to connect to the device. So when I hit this button, what's going to happen is it's going to go through the discovery and connection process. Now, because Bluetooth Classic supports server-side, in theory, I could write my embedded device to be constantly looking for new things. My app could just open a server connection and accept the first connection that comes in. I wrote it the other way. There's really no reason for that other than that's the way I did it. So if I come in here, I can hit this connect button. What it's going to do is discover for a device that has a specific name, because I've set this controller device to have a specific Bluetooth name. And as soon as it finds it, it will just automatically start connecting to it and jump me into the game. Okay? And hopefully, it'll just work like that. So we're scanning for devices. So this is doing discovery. You can see discovery does take a little while. Now it's found the device, so it's going to connect to it, and now I'm in my game. So the purpose of this game is for me just to drive my little Android around the screen and try to pick up the Ruby. So if I get to the Ruby, I can hit one of these little buttons. And you can also hear there's some vibrator feedback in the controller. So when I either positively or negatively am able to do that, the controller will vibrate back at me. Okay? So I'm doing a little bit of two-way communication as far as the controls going this way and the feedback coming back to the device in this case. So I can drive around, pick this up, and it'll just continue to go. So you can notice I'm not connected to the device at all. This is all happening over Bluetooth. I'll show you the same example here in a little while using USB, but in this case, we're talking Bluetooth here. And of course, the killer feature, if I hit the other button, changes color. That's the one that's going to get me the 5-star review, I think. Okay. So let's take a look at the source code for that guy. So I won't spend too much time on the game itself. By the way, this source code is all on my GitHub. It's just github/devunwired. I'll share that link again at the end. It was on the first slide as well. But all of this project is up there for you to take a look at. So I won't spend too much time on the game, but the game activity is where all of those drawing pieces are. So I mean, that's where it's actually drawing the player and receiving the input events and moving it around. Yeah, question? I'm just curious, for a game like that, what's the throughput you can do on Bluetooth? Sure, that's a good question. I can't say I've really tested it. Oh, sure. The question was, what kind of throughput do you get, out of that controller? I can't say I've really tested that much, but the protocol that I'm using is very simplistic. All those data transactions are happening in about a 3 or 4 byte payload, so it's not really taxing the system at all. I would say that you can do pretty well with it. You could probably get into the high kilobytes per second. I don't know about megabits per second, but I don't really have any numbers to back that up either. So, play around with it and see what you get. Yeah, question?
I mean, if it's RFCOMM, it's adequate for streaming audio, right?
Yes, absolutely. RFCOMM would be adequate. Well, RFCOMM is not designed for streaming audio. It's a different protocol profile, but it's the same channel that, yes, is adequate for streaming audio. So it is capable of doing that. It's absolutely true. Question?
Yeah, can you modify the packet size and interval duration?
Can you modify the packet size and interval duration? As far as I'm aware, no. Those implementation details are specific to the Bluetooth stack, and they aren't exposed as APIs.
For iOS at least, you can change the NPU.
Yes, in iOS you can.
Okay. So
But the Android APIs, as far as I'm aware, don't expose that at the packet level.
you know what size it is?
I don't. I don't off the top of my head. It might be in the documentation, but I haven't looked. So, okay. So what we're going to focus on instead is the Bluetooth connection side of all this. Okay. So I have this activity here, and we'll come in. We'll go up to the top here. So when I go in and I hit that connect button, what's going to happen is a couple things. We're going to register a broadcast receiver because in Bluetooth Classic, the device discovery comes back to us as a broadcast. Okay? So we're going to register a receiver for those actions, and then we're going to attempt to start discovery on the Bluetooth adapter. Okay? So then that's going to trigger my receiver here every time a new device is found. So for each device that it finds, it's going to verify that that controller's name and device class match the values that I've specifically hard-coded for my controller. Okay? So that way it knows when it finds the right device, and any other devices it's just going to skip over and ignore. Okay? So then once I've found it, I'm going to go through and again start connecting to the device. Now notice the other thing that I do, as soon as I found the device I'm interested in, we're going to cancel discovery. Okay? Remember, a discovery is a high-power operation, so I don't want to keep wasting the radio and battery time once I've found the device I need. Okay? Now, if for whatever reason I don't find that device, what we're going to see instead is a discovery finished broadcast saying, I'm done looking. If you didn't find what you're looking for, I'm sorry, try again. Okay? So it is a finite scan that at some point will time out. But sometimes we may, usually we'll find the device before that happens and we want to cancel it ahead of time. Okay? All right, so we'll go look at the thread here. So what happens is once I have the reference to the device I'm interested in, I'm just going to attempt to connect to it. So notice I'm using that insecure RFCOMM method. So I'm using this because I don't want to have to manually pair to the device. You notice nothing came up on the screen. I didn't have to enter a PIN code or anything like that. It just connected. Okay? And this helps a lot. Now, at some point, the two devices will be bonded together anyway, so you don't have to worry about this. This is more of a first-time problem, because after they're bonded, it doesn't matter. You don't have to pair anymore. But at least in the initial stage, you need to worry about that. Okay, so this create method will generate one of these Bluetooth sockets. Now, this doesn't take very long. This is sort of a local operation. What's going to take a long time is when I hit connect. So connect is going to block while the Bluetooth stack goes and attempts to make a connection to that device. Okay? And then it's either going to throw an exception when it fails, or it's going to continue on if everything went okay. Okay? So assuming everything went okay and I don't fall in here, we're going to get our input and output stream for the Bluetooth device. Okay? Now, at this point, I can do whatever I want. I have a raw input stream and a raw output stream, and so my Arduino device, alongside with my Android application, I've just pre-written a basic 3-byte protocol that transfers individual data back and forth. Okay? And again, like I said, if we have time, I can show you that on the Arduino side. It's really just for each sensor value, spit this out over the Bluetooth stream, and it shows up in here, and same thing the other way. Okay? So it's just parsing random bytes back and forth. Okay? But from a Bluetooth or from an API's perspective, at this point I'm done. I have 2 open connection streams that I can read and write data freely back to my device. Okay. All right. Let's take a look at the next one. All right, so the next one that I'm going to show you is a Bluetooth LE example. Now, I'm going to admit up front, the Bluetooth LE stack is still a little shaky, and sometimes this demo doesn't work. Don't blame me. Okay. Even so, this is a sensor tag. It's made by TI. You can get one of these for like 25 bucks. It's got 6 or 8 different sensors on it that you can connect to this device and read the sensor data, any way you'd like. Even TI's application on Google Play doesn't work all the time. That's how I know it's not my fault. Yes.
Right. So this is a great no fault of your own.
Sure. So the question is there a best practice for when the Bluetooth stack just screws up? Yeah. At this point, what I've noticed is that, and this is another reason I know it's not my fault. During all the callbacks that happen on a GATT callback, during connection state changes, the return value will be something that is completely undocumented. So, I mean, there's basically only 3 documented states, or 4. There's like connected, connecting, disconnected, disconnecting. If I get a callback and it has one completely off the wall state, like the Nexus 7 sometimes will kick back 130 and I have no idea what that means, that's usually a pretty good idea that the stack is completely hosed. And I'm going to have to actually toggle the Bluetooth, enable and disable it to be able to get things back working again.
It sounds like you're saying these are weaknesses in the Android implementation.
Absolutely.
Okay.
Yes. And it's one of the reasons that at least today I like leaning towards beacons because I don't have to deal with connections. I just have to do scanning. Because the issues are always in dealing with getting connections set up.
And the device you're holding is a beacon on the broadcaster?
No, this is a connectable device. So basically, this is a GATT server, and each individual sensor on this device is exposed as a service. And then each service has characteristics like the sensor's value, ways to configure its update interval, and stuff like that. So this device we're actually going to connect to, which is why it might not work. All right, so let's give it a shot. So what we'll do here, so what I've created, since this is all sensors, and don't shoot me, I'm not a designer, but I've created just a very basic weather station that's going to read some of the sensor data off of this device. Okay, so if I wake this device up and attempt to scan for it, I should see it pop up in my list here, and then I can try to connect. Hey, that was the fastest it's ever done it. There we go. So it's connected to the device, and actually what it did in all that time was it connected to the device, enabled, in this case, 3 of the sensors, read their values, and set characteristic notifications. Okay? So if we sit here long enough, you see some of these values are changing up and down because I'm getting updated from the device using notification. Okay? So I'm not polling continuously. I'm just getting callbacks and on-characteristic changed every time one of these guys gives me an update. And the update rate for most of these sensors is a couple times a second. So it's not really streaming data to me, but it's regular enough for an application like this. Okay? So then I can shut the device off, disconnect it, and everything's good. Hooray, that one worked. Okay, so we'll look at the basics for that. So if we go into my Bluetooth GATT sample here, our activity. So in this case, what we've got going on is that I have some methods for starting and stopping a scan. And these happen when I press that button in the action bar. Okay? So when I hit scan in the action bar, it's going to start a scan by calling that start LE-scan method. And notice I pass a parameter to it, which is the callback where I want the results to come back in. So I've implemented that on this activity.
Sorry, where did you get the adapter?
Oh, sure. Great question. So where did I get the adapter from? And this is actually a little bit different than Classic, so thank you for the question. In Bluetooth Classic, there's a static method that just says Bluetooth adapter.get default adapter. With Bluetooth LE APIs, and really this is true for Bluetooth in general, starting in 4.3 forward, there's now actually a Bluetooth manager, like any other system service. Okay? So there's a Bluetooth manager, get system service, and I get the adapter from there. Okay? So it is a little bit different than on the older API structure. Good question. Okay. So when I start the scan, I just get that, and I've set up a handler to trigger my stop after a couple seconds. So I don't want to scan continuously. I just want to try quickly, see if I can find it and move on. Okay. So then onLEScan is going to be called every time I get a new device. So again, kind of like I did before, I'm checking to see, or I'm figuring out whether or not it's a sensor tag device. So if I had more than one, they would have showed up in the list, but I only want sensor tags. I don't want all the other Bluetooth LE devices that may be sitting around in the room at the moment to show up in that list. So I'm checking that, and if they are, I'm adding it to this collection that makes up that menu. Okay. And then at some point later, when I go back in, so that's all just implemented as part of the options menu. That's why it's in the action bar. So if I then select one of those options later, I go back and pull that device out and attempt to connect to it by simply calling connect GATT. Okay, so connect GATT takes a callback for all the other things that are going to go on inside of this. So connection changes, service discovery, characteristic read write, it's all in one instance. Okay. So and what I've done, as I mentioned before, you really have to deal with these one step at a time. So I've sort of built this into an advancing state machine that I can click my way through to enable all the sensors and get all that going. So we've got a method where every time I move this forward, I'm going to enable the next sensor and the next sensor by simply getting a reference to that characteristic. And I should point out real quickly, let me do that, that each of these are just UUIDs. Okay, so everything that I put that's a service or characteristic reference is just a UUID that is documented for that sensor tag in TI's documentation. Okay, so this is how I know where to get these UUIDs from. Yes?
Can you ask a device for the UUIDs that it supports?
Yes, you can. That's called service discovery. So the question was, can you ask a device for its UUIDs specifically and get a list back? You can do that for all service UUIDs, and then you can ask a service for all of its characteristic UUIDs. So you can do both of those, and in fact I do have them in here somewhere.
That's before you're connected or after you're connected?
After you're connected. You have to connect first, which is true in Bluetooth Classic also. So the same thing happens in Bluetooth Classic, you have to connect first.
Excuse me.
Yes?
So to clarify, like when you're unconnected, you can get kind of the beacon type information, right?
The advertisement, yes.
Mm-hmm. And after that, you can get characteristics and services?
That's correct. So you have to connect first to get characteristics and services. Only the advertisement data will come prior to that. And I mean, that's true. That's really true of all Bluetooth devices. It just happens that in Bluetooth LE, we started to turn the advertisement into something interesting. So, okay. Oh, question? Yes.
So with the start, I mean, do you anticipate like going further with the advertisements, like more than like 27 bytes?
I doubt it. So the question was, do you think that we might expand that at some point? I mean, well, first of all, it's part of the Bluetooth spec, so it's up to them. But I don't know that that's necessarily going to be the case, even with the popularity that beacons are achieving, just because at some point you start to impact the power capability of these. I mean, these advertising packets are small so that we can quickly get them out there and do it on an interval. If they start to get real large, then that becomes a trade-off with that. So it might happen, and it might get a little bigger, but I wouldn't expect them to grow to the point of a full GATT server table, just because that would really impact the power performance. So I think there's a trade-off there as well. Yes?
Isn't there extended advertising packets?
Are there extended advertising packets? I believe there are, yes, but they're not, at least in the Android APIs, supported. Yes?
Can you speak at all to what the physical layer looks like? Is this CDMA of some sort? Are the devices backing off when they see it? Other people talking? How does this work?
You know, I'm definitely the wrong guy for that question. Yeah, I don't really know much about how the frequency hopping and the actual radio layer really works. It's well defined. I mean, that's all documented on Bluetooth's website, but it's definitely not my specialty.
Got it, thanks.
So one more, and then we're gonna keep going.
In this state variable, it doesn't look like you come in with defined state and you're not incrementing it through your loop.
Sorry, that's all done here. So what I'm going to show you here is what's going on here in a second. And this is just something I architected around the API. It's not really part of it. But so for each sensor, we have to get a characteristic, and then for enabling it, I write a value to that characteristic to enable the sensor. So one of the characteristics on this device is turn this sensor on. By default, all the sensors are off because sensors take power. So you only turn them on if you're going to read their data. Same thing, there's one for reading a sensor, which is again just reading a specific characteristic value to get its value. and set notify, which is just a wrapper I put around to allow a specific characteristic to have its notification enabled to start pushing data back to me. Okay? So, and again, that's a two-step process. I have to set it locally in the GATT server database, and then I have to tell the device by writing what's called a descriptor. A descriptor is just a portion of a characteristic. Okay. So, and I'll get to the advancing there in a second, but just to mention this, so on-connection state change is where it'll tell you now we've connected, we've been disconnected, or I'll get one of those whacked out values because something is completely hosed. Okay, that's all going to come in here. And so you mentioned the discovery. So discover services is that method that would start the process of give me back a list of UUIDs for services. Okay. And then there's an on services discovered, in which case you would have them at that point. Okay. But so here's kind of how we're gearing this is inside these callbacks. So when I get services, I start with the next sensor, reset my little machine and start with the next sensor. Then on characteristic read, I do set notify. On characteristic write is the read. So we kind of go through these with each callback. And then at the very end, here inside of the descriptor write, because the last thing that I do is set notify for that sensor, I advance to the next sensor and do it all again. Okay. And this, the TI source code does something a little bit different than this, which kind of stinks and might be why their app doesn't work very well either. They don't wait for the callbacks. They just block the thread for 100 milliseconds and then try the next one. So they just assume that it's only going to take this amount of time and then we'll try again, and they completely ignore the callbacks. Okay. Yes, question?
All this code is in the Android activity, right?
Right now, this is all in an activity, yes.
Can you think of a use case where it would make sense to put this code in created as part of an Android service?
Absolutely. So would you ever want to put this code in a service? In production, probably every time. It's just simpler to do in an example inside of an activity. Yeah, absolutely. Okay. Oh, question?
Are these UUIDs for like pressure sensors and whatnot fairly uniform across manufacturers?
No. No. I mean, so the question was, are the UUIDs uniform from one device to another? If they're conforming to a spec, yes. So if this is a health thermometer profile which has a specific thermometer characteristic in it, that will always be the same UUID. But this thing that TI made, they made up their own UUIDs for all their services, and if somebody else makes their own tag, they'll probably make up their own for that. So unless they decide to conform to the profiles defined, that's really what interoperability is all about. They'll be making them up for whatever they want. Okay, all right, so let's keep going here. So then just, some additional callbacks. So that's all in this. So all we're really doing after I hit that connect button is it's just going through and enabling sensor read characteristics set notify, enable read set notify, enable read set notify. And then at that point, what we're going to get is on characteristic changed from here until I disconnect. So I've set notify on all those sensors. So the sensors are just going to push data to me, and I'm going to get this callback whenever I get new data. Okay, so I'm just figuring out, okay, it was this characteristic or this characteristic, and notice I'm posting those all back using a handler because I can't update the display from here. I'm not on the main thread. Okay, so all I'm doing here is posting those characteristics back so that inside of a handler, let me go that, I can read those characteristics out and actually touch the views. Okay, so that's all we got going on here. All right, I'll show you the next one. Lots of fun demos today. Okay, so the next one I'm going to show you is much, much simpler from a demonstration perspective, is a beacon monitor. So what I've placed around the room, there's one right here in front of me, there's one back there on the beer, and there's another one over there. These are beacon devices that are pushing to me a temperature value. Okay. Now, so these are not iBeacons, they're not Estimotes or anything like that. These beacons are actually made by a company in Colorado called KST. KST is actually going to be out here on Friday for that hackathon. So if you want more information about them, come back on Friday. But these beacons really just, everything you see here for each of these elements is pushed to me in the advertisement data. I'm not connecting to these devices at all. I'm just simply running a scan every 2 to 3 seconds for about a second or so, and then stopping and scanning again. Okay? And that's just so that I can pick up the changes in the beacons each time. This is actually what I would consider a deficiency in the Android stack. Right now, the APIs don't allow me to stay scanning continuously and get changes in advertisements. It will, if I discover the device once, It's just going to say, well, you've already seen that one, even though the data in the advertisement that I want has actually changed. So we actually have to toggle the scan on and off periodically. Okay? So part of the trick is figuring out what your update interval is on your beacons and trying to sort of time those two things so that they work well together. So the values that are in these is just the device name, that temperature value, which is blocked in service data. So it uses the standard Bluetooth UUID for a thermometer and says, for that UUID, here's the temperature. And it just gives me a temperature value in Celsius that I can convert and stick up on the display. Okay? Now, I put one on the beer hoping it would be a lot colder, but I think we may have only lost half a degree on that one back there. So.
It's not in the kegerator.
That's true. I was afraid if I put it in the beer, then it might not connect well or something like that. So didn't want to ruin my demo or anything. So there you go. So that's all this is really doing. It's just regularly scanning and posting that information. Okay.
So is that the expensive scan?
Is that the expensive scan? Is there any scan that's not expensive? I mean, Bluetooth LE scanning is lower power than a Bluetooth Classic Discovery, relatively speaking, but it's still turning on a radio. It just happens to be turning on a radio in receive mode instead of transmit mode. Yes, question?
Why can't they match it so the devices agree on, time window and you don't have to have too much margin on the listen?
Well, so why can't they match the connection intervals, or the advertising intervals, you mean, so that they're consistent?
If you have to listen, I mean, say an interval only comes maybe once
Sure.
every 5 seconds, right? You'd only have to listen
Yeah.
for whatever, 0.1 second above that 5 second and 0.1 second below it, have that scan interval to make sure you.
Yeah, absolutely. The real reason that the Bluetooth spec doesn't specifically force those to certain things is because the advertisement packet is probably the one thing that governs the battery life of that device. The less I advertise, the longer my battery lasts. So it's really depending on the application how frequent or infrequent they want those advertisement packets to be pushed out at an interval. Because if I do it every second, my battery may only last a week. If I do it every 10 seconds, I may last a month. So, yes?
That kind of begs the question, why isn't there a standard UID for refresh interval?
For connection interval?
Yeah, re-advertising interval.
Right. So the question is, why don't they publish the connection interval? The answer is actually they do. Inside the advertisement, but of course it's not required, but there is a service data entry that you can use for advertising your connection interval. But that's actually the connection interval, not the advertising interval. So the reason that it's in there is so that devices that can accept connections know how to synchronize that with making a connection to the device. So I guess I kind of answered the question backwards in saying that the interval for the advertisement is not by default provided in there. Now, they could put it in there. So a manufacturer, let's say KST wants to add that to their beacon so that one of the service data elements they provide is the advertising interval so that you can kind of get one and lock on it. I think that's a great idea, and they could definitely do that. The space is in the advertisement to make that happen. It's just not part of the spec. So, good thought. Okay. So let's take a look at this source code. So this source code is pretty straightforward. So just like before, we get access to our Bluetooth adapter. We verify. I didn't show you this before, so I'll show it to you quickly. There are ways to determine whether or not Bluetooth is enabled or not. And basically, if you don't get an adapter, or if the adapter has its is enabled set to false, then you're not going to be able to do anything else because Bluetooth is actually disabled in settings. So what we're doing here instead is firing off an intent which kicks off settings that tell the user, I want to use Bluetooth and you shut it off, so could you turn it on please? And then that will come back in and then we can go through this process again. This is that check for whether BLE is supported. So does this device have the BLE feature? Should we even continue in this case? Okay. All right, and so then by default we start a scan. So in this case, notice there's a couple little differences here, and this is another neat thing you can do with the Android APIs when you're talking to beacons. Start LE Scan actually has a version that takes another parameter, and this is an array of UUIDs. If you know that your data is in the advertisement packet, you can ask the framework to only return to you devices that have certain UUIDs in the advertisement. Okay? So here I can say, well, I'm only interested in these temperature beacons that have this thermometer UUID in the advertisement. So if there's a ton of other beacons in the room, which there probably is around a place like this, I'm not going to get them polluting my list. You know, I'm not interested in them. I don't know how to parse their advertisement data. Just give me back the stuff I want. Okay? So you can really clean up your code by letting the framework do the work for you and sort of parsing those out ahead of time. Okay? Yes? Can you create an ad hoc network? Can you be more specific?
Where you have a certain set of devices that belong to this temporary network, kind of like the ID does.
You know, I suppose to some degree that's true. You could use this as a mechanism for grouping scans. So you could say, I want to scan for this set of devices and then this set of devices. Whether I would call it a network or not is a different story. But I think I understand what you're saying, and yes, you could. Okay. All right, so we start the scan, and you can see that just like before, I'm doing this sort of auto trade back and forth, but now instead of starting the scan and automatically stopping it, I'm also, every time I stop it, automatically scheduling a new start. Okay, so I'm just toggling back and forth, continuously scanning, so that each scan I can get new data from these beacons. Okay? And then inside of onLEScan, I don't care about connections anymore. What I really care about is this scan record now. Okay, so the scan record is where all that AD data is. So, and I mentioned before, I've basically just created a very simple parser that takes that byte array and chunks it out into these little data objects that are AD records, which is just their length, type, and raw payload. Okay, so I mean, we can take a look at that, but it's just a very basic parser that chunks the data out and returns it back so that I can use it in a more useful fashion. Okay, and then I've also got reference to another object I've created called a temperature beacon, which will take the pre-parsed data of all those records, search through it for the ones I care about, in this case the device name record and the service data record, and pull those specific elements out to display the name and display the temperature inside of my list adapter. Okay? So in here, and I've got some additional helpers so that when it is a name, I know how to parse that byte array, and when it is service data, I know how to parse that byte array. And at least for the KST beacon, the temperature is quite simple. It's just 2 bytes, with the lower byte being the temperature in degrees, and the higher byte being flipped or not if it's half a degree, because the resolution is only half a degree C in this particular sensor. Okay? So this is obviously going to be specific to the device I'm working with. If you're playing with a different beacon, your format will be different. If you're playing with the Cupertino Fruit Company beacon, you have a secret protocol that people have reverse engineered but isn't technically public yet. Well, actually, that's not true. They made it public yesterday as part of MFI, so you have to sign a bunch of legal contracts first, and then you can look at it. Okay. So that just creates one of these objects that we can display it in the list. And then we just have a basic adapter to show them all there so that you can see the content. Okay? All right. Let's see if I can fly through the next section so I can show you the USB stuff. All right. So the next things that I kind of want to walk you through here are USB communication. So there's 2 major modes in which we can use the USB on our Android devices to connect to accessories or other external hardware. Okay? There's Open Accessory and there's USB host. Okay? Open Accessory is what we're going to talk about first. It's a protocol that they added to the Android APIs in 3.1. At the time, they also backported it using the Google APIs library to 2.3.4. Most devices now that are running Gingerbread will have this, but it used to be that the safest way is just to only support 3.1 and later, which here pretty soon won't be an issue. But it is in both. And what this is it's a way for an Android device, which in USB terminology is a device, not a host, to act as a USB host. So the difference between the two being, a USB host is typically like my machine here, and a USB device is my phone. And that means a couple different things, both protocol-wise and electrically. So I mean, electrically, a USB device gets power from a USB host. And that's a one-direction thing. So if I want to charge my phone, there's power in USB to let me do that. And the host always provides the power, the device always consumes it. Protocol-wise, that also means that the USB host device is responsible for initiating all communication. A USB device never initiates anything. It always responds and reacts. Okay? So device enumeration to figure out what a newly connected device is, sending commands to get basic information, that always comes from the host. But the roles are kind of reversed when we're talking about a USB accessory, because if we want to plug this into our phone needs to act as a host without technically being one. From a USB perspective. And so that's really what Open Accessory is designed to solve. Okay? It's an embedded protocol that allows the USB accessory to be the host and interact with the Android device as a USB host, but make it look to the application like it's still the device or the accessory. Okay? So we'll take a look at what that really means. That does also mean, though, that the USB accessory is responsible for powering the phone. Okay? So now it is possible to create a USB host that doesn't have 5-volt power in it, but it's not real easy, because 5-volt power is also used to connect the detection, or detect the connection, in addition to actually providing that charging power. So if you're trying to create a battery-powered accessory, it's also going to be sending current to the phone to try and charge it, and that's just a design consideration you have to keep in mind. Okay. Okay, so the way this works, there's two different versions of it. AOA 1.0 was the initial version. This really was designed to just create a single basic interface between an embedded device and an application. And in USB terms, it manifested itself as a bulk data transfer, similar to a mass storage device, which is kind of like when we talked about the RFCOMM. It's just a dumb pipe that allows me to shovel data back and forth. It just did all the work of hooking that into a specific app for me. Okay, and then on the embedded device, I just have the same pipe on that side. In Jelly Bean, so 4.1, they added some new features to it, and they're what they call AOA version 2.0. So in addition to the application stuff, they added support for audio accessories, so that an Android device, when you connected an audio-based accessory, could treat that as an audio route and transmit its audio data out over the USB connection to, say, a Bluetooth-enabled or a USB-enabled speaker. Okay? But it wasn't the same as traditional USB audio, because it had to use Open Accessory, because in traditional USB audio, the speaker is a device, not a host. Okay? So we had to sort of flip things around a little bit. In addition, they added another feature that I haven't really seen used much yet, but it's this idea of an HID port forwarder, I guess you could say. So same basic idea, that if I wanted to plug a keyboard into my phone, a keyboard is typically a device, not a host. And so it responds to input, not initiates it. And that's what an HID device typically is, a mouse, keyboard, joystick, stands for human interface device. They added these features to the accessory protocol so that I could write an embedded little program that would take data and push it into the Android device to make it look like the data it would have gotten from a traditional HID. Okay? So HID devices transmit their data in these structured formats called reports, and typically they hand them back when they're asked for. But this accessory protocol allows an Android device to have them shoved into it and have it react the same way as keyboard or mouse or whatever that HID device is reported as. Okay? It's kind of an off-the-wall feature. I haven't really seen it used much, but the support is there. Okay. I won't focus on this too much. This actually goes through how you implement the protocol, but some of the basics are, because the host, or the host, the accessory is in control, it's up to the accessory to reconfigure the Android device to be in accessory mode. Okay, so in general, when I just have my device hanging out, or when I plug it into my computer, that USB driver on the device is in a completely different mode, where it responds to things like ADB and deals with charging, but it doesn't have all this accessory stuff enabled. The way that works is I have to plug in an accessory that, as a host, starts pinging the Android device with commands to determine if it supports AOA, what version of AOA it supports, and if it does, it physically has to reboot the USB driver on the device to turn it on accessory mode. Okay? And it turns on, the way that they identify that is using the vendor and product ID, which are two identifiers that every USB device has sort of burned into it. The vendor ID for Google is always static, and the product ID tells us whether it's in accessory mode or not. So if it returns back an incorrect product ID, the accessory tries to reboot it again and see if it can get that to work. Okay? So on the embedded device that I have, the code to make all that work is written. So I mean, we can show you that in the Arduino stuff, but it's specific to the embedded implementation. Okay, similarly with 2.0, it worked the same way. The only difference was before you sent the command to reboot the device into accessory mode, you added additional commands. So you'd say, before you do that, set audio mode, because I have audio that I want you to send to me. Or set these additional HID parameters, and then when you reboot your device into accessory mode, it will have those features enabled. Okay, so same process, just some additional commands. Okay, for those of you who want to play around with this stuff, there's a number of different kits out there. The 80K, which is the one that I have here, you can buy directly from Arduino. Yours will look a little different than mine because this one I got at Google I/O, but now they're blue. But it's the same basic hardware. You know, it's an Arduino. From an Arduino perspective, it's an 18 mega with a USB shield that you would typically stick on top, soldered directly on the board. Okay, so that's really what an 80K is made of. But there are also other projects out there. You know, there are actually 2 different versions of the Arduino now that support this AOA type communication. There's the Arduino Mega that I have. There's the Arduino Due, which is a much newer processor. It's actually based on a 32-bit ARM Cortex M3 chip, so it's much more powerful. And so because of that, it also has its own USB stack on it. Some of the basic microcontrollers, like the PICs from Microchip and FTDI, all support actual existing libraries for AOA. So I mean, if you're using that microcontroller family, you just go to the vendor, get that shared library, and drop it into your microcontroller project, and you don't have to write the protocol. Okay, so there's a number of these out there. We also have listings to the documentation there. The one for source.android.com is the most interesting to me. If you're interested in actually having to implement your own AOA protocol on whatever chip you're working with, the steps that I just showed you on the previous slide for here's all the protocol commands we send and in what order is defined. That's all that documentation is on source.android.com, not the developer site. Okay. All right, so just a little bit about the accessory APIs. You know, the USB accessory APIs are a little bit different than what we were dealing with Bluetooth because they include this idea of reacting to the physical connection rather than sort of going out and initiating it some way using device discovery or something like that. So if your accessory is already connected to your device, you can ask the USB manager to get a reference to that, you know, by just saying, give me a list of the accessories that are connected and determining if the one that I want is already there. But there's actually also a format that allows you to auto-load an application based on an accessory connection. Okay? So part of the embedded firmware that I have on this device is it includes some definitions for a manufacturer, model, serial number, version. There's a number of different strings that actually get reported from the accessory to the Android device. I can then set up in an application filters for that data. So I basically define an XML file that says if an accessory that is of this version, this manufacturer, so on and so forth gets attached, I want to use it. And then the Android framework, when you connect the device, says, we found an app that uses this accessory, would you like to launch it? And just does that whole thing automatically. One of those strings is actually also a URL. And the purpose of the URL in your embedded device is that if your app is not installed yet, when they connect the accessory, it will say, we haven't found an app that works with this accessory. Would you like to go to URL X to find it? So typically people would put their Google Play URL or something like that embedded on the device for that to work. Okay? So there are actions for attach and detach, and when you register for an attach action, you give it that filter, and that's how the framework knows we should launch this app, this specific component. Okay, I'm going to go through the rest of this before I show you the demos. But in addition, we have this idea of host mode. So this is more commercial type USB communication. So there are many Android devices. It used to be just a tablet thing, but now we're starting to see it on handsets as well, where the devices support USB host as well as being a USB device. Some of them use you might have heard a term called USB on the go. Really, that's just both versions in the same connector. It's an electrical specification. It just means that the device can be either a host or a device. It can still only be one at any given time, and it makes that decision based on what it's connected to. But it really just means that it can support both protocols. Okay? So because of that, we actually have the ability to hook in commercial USB devices that you would just buy off the shelf and work with them inside of an application. So for instance, the example I have is I have a postage scale that I got from Staples, and I can plug that into my tablet and communicate with it and write an app that talks to that scale. Right? I mean, this is not something I wrote or coded, I just bought one. Okay? So because we have the host capability, we can kind of work with that. All right. So just a little bit about USB devices. USB devices are built up of endpoints. They're sort of the smallest building block. An endpoint is the element that you actually connect to. You know, and there will be endpoints grouped together by their function. So there's a number of different endpoint types. There are control endpoints, interrupt endpoints, bulk endpoints, and isochronous endpoints. The first three are allowed to use inside of an app. Isochronous endpoints are not enabled for apps. They actually are supported in the framework because that's how they do the USB audio stuff with an accessory, but an application cannot talk to an isochronous endpoint. It's not supported in the APIs, okay? But control endpoints and interrupt, those are typically used for simple commands. Like there's a command for me to zero the scale. That's a control command. The interrupt sometimes will have small data messages, and bulk transfer would be like flash drive, right? I open up a bulk endpoint and start shoveling data back and forth in large mass, okay? Those endpoints are then collected together in interfaces. So an interface is what you would think of as a logical device, you know, and the reason that it's not the highest block, which is a configuration, is that a single physical device might represent itself as more than one logical device. Think of like a multifunction printer, right? It's a printer, a scanner, a fax machine, and those are all devices that show up on your machine when you hook it in. Each one of those is an interface that are members of a single configuration, okay? So that's kind of how that all breaks up. And the reason those terms are important is because the Android APIs line up exactly with those terms. The Android APIs don't give you much in terms of higher level access. You just get to enumerate descriptors and enumerate configurations, interfaces, and endpoints. And you have to know what those endpoints are and how to talk to them, because all they're giving you is sort of that very thin layer, okay? This is just the way that devices report their capabilities back to the host is using descriptors. So I just wanted to give you sort of an idea of what descriptors look like. You know, these are standard descriptors for, in this case, the device as a whole and the configuration for that device. And they report things like its vendor and product ID, how much power this device is going to need. All that information is resident in descriptors on the device. Then there are other descriptors for string values. The interface has its own descriptor to report how many endpoints that interface has, what type of interface it is, all that information. So the host during enumeration just goes through and says, give me this descriptor, and that's how it knows what kind of device it is to configure on a desktop, the driver for it. But you know, here in Android, how we're going to configure our app, right? Okay, USB host APIs are very similar to the accessory APIs, so we'll kind of breeze through this, but you still work with USB Manager. If you want a list of currently connected devices, there's a get device list instead of get accessory. And similar to the connection, there are events for getting an attachment or a detachment of a device. And just like with accessories, if I want my application to only respond to connections from certain USB devices, I can create another one of those filters to say only launch my app if the device has this vendor ID, product ID, interface class, you know, so on and so forth. There's a number of different fields in there. In both cases, with devices and accessories, if you set that filter and make it empty, you will filter on any connection from any device. Okay, so it is possible to do that. All right, so when working with USB devices, and to be honest, accessories too, the user is always involved in that process. So either a connection is made and the user sees a dialog asking if they would like to launch your app, or when you go to connect to an existing device, they will get another dialog that says, do you grant permission for them to use this app, or for the app to use this device? Okay. The first dialog implicitly grants permission when they say yes, so they'll usually only see one or the other. But you can never actually connect to a USB device or accessory without going through that user dialog first. Okay. So once you've requested permission and it's been granted to you, then you can open up a connection, and you know, that's where things like open device come in, and we can start claiming interfaces and transferring data back and forth with this device. It turns out enumerating the information on a device we don't need permission for. So things like get interface, get endpoint, I can do those on any connected device without permission. So I can figure out what this device is first, I just can't open communication to it. At that point, if I don't have permission, things will start failing. Okay? All right, and then just actual data transfer. There's a number of different ways to do this. There are USB requests, which is an asynchronous model and can be used for bulk endpoints or interrupt endpoints. This is something where you initialize a request and you just say queue it up, and when it's done, let me know. And then later on, you can check. This is actually a polling mechanism. You have to check back later and see if that request has finished, and it will tell you that. The remaining two, the bulk transfer and control transfer, are used specifically for bulk endpoints and control endpoints. But those are synchronous. So those, I call the method and it will try and then return back when it either succeeded or failed or timed out or something like that. Okay? I will say, having played around with this recently, that all of these used to work really well in the 3.0 days. The USB request stuff is kind of broken recently. So if you're dealing with having to talk to an interrupt endpoint and trying to do that using USB request, that doesn't seem to work so well in Jelly Bean. Used to work fine, and now there's some bugs in there. It seems to work fine for bulk endpoints still, but the interrupt stuff has been acting a little goofy lately. So if you're dealing with that and you've had similar problems, I'm with you. Okay, so let's get these last demos in here. All right, so the first one that I'll show you is just a rehash of what we had before. I'm going to play my game again. But this time what we're going to do is I'm going to take my controller and I am going to plug it into my Android device instead. You always do it the wrong way first. What's that? Unless you're Apple, that's right.
So who's powering who now?
So notice that the controller is actually plugged in.
Yeah.
And because this is a host port, it will be providing power to my device. Okay? So I don't know if you'll be able to see it or not. Yeah, you actually can see it. When the status bar comes back, you'll notice that the charging symbol is actually on. Okay, so when I connect it, what I get is this dialog, because I have my Accessory app already installed, and it knows which application because I've set the filters correctly. And so when I connect it, it immediately says, would you like to open the controller app and start playing around, or would you like to not? I could hit cancel and nothing would happen, but I'll go ahead and launch the app from here, and it just immediately jumps me into the app, and I can play my game again, except I've got my controller upside down. So now I'm playing the exact same game, but now I'm talking over USB instead of over Bluetooth. Make sure to change the color. Carry that. So same basic functionality, but now I'm using, in this case, Open Accessory. So Open Accessory opens up that same raw input and output stream between me and my Arduino, or the Android and the Arduino device. So I can even use the same accessory, because at the end of the day, it's just pushing the same data just over a different pipe. Now it's going over USB instead of my Bluetooth shield that I have in between the two. Okay? All right, so we'll unhook that. Maybe. There we go. So let's take a look at the code for that guy. So in here, well, let me show you a couple things actually. We'll start with the manifest for this and a couple other pieces. So if I bring up some XML, come back here. Okay. So inside of the USB activity, notice I have an extra intent filter besides just the main launcher for an accessory being attached. Okay. And in addition, I provide some metadata that points to the filter XML for when that action occurs. Okay? And then the filter looks something like this. Let me actually change it. So these are just some values. These are all string values that are defined on my controller. There's manufacturer, model, version, serial number, and URL. I think those are the 5. And I can put as many or as few in here as I would like to filter on. So for instance, let's say I had several accessories from my company and I want to filter on anything that has the same manufacturer. I just put that one in there. Okay? So I can do that, and then this in concert with what's in the manifest is how I get that dialog to automatically pop up when I plugged in the accessory. Okay. Now, by the same token, I may need to get it ahead of time. So if I didn't come in for that reason, if I just jump into the app, I may want to check to see if the accessory is already connected first. So in that case, that's why on resume here, depending on this result, I may go to see if there are any accessories, and if I've already got one, check to see if I've got permission for it already, if the user's already clicked OK. And if so, then I can just jump right in and start doing things. But if not, I have to request permission first. And then notice request permission takes that's actually a pending intent. So I pass it a pending intent, and then when the permission is either granted or denied, it triggers the pending intent back to me, which in this case, the pending intent is a broadcast, I think is what I have set up. Yeah, I set that up as a broadcast. So that fires inside of my broadcast receiver when the user has either granted or denied permission. Now, depending on how you want to architect your app, this is actually a nice simple way to do this where even if the user has already granted you permission, in that case, if you call request permission, it will just immediately fire your intent. Okay? So sometimes it's safe to just create a code path that always calls request, and one of two things will happen. Either you'll jump right in, or you'll involve the user first and jump right in, but the code will work the same way at that point. Okay? But then in any case, once I have the accessory that I'm interested in, I can go in and call open. So open accessory is a method that I wrote that really just takes the accessory instance I've been given from that discovery connection process, and out of that always comes a file descriptor. Okay, so when I open an accessory, what I get is a file descriptor, which is really just a file handle to the driver. It's just abstracted a little bit. And then from there, a file descriptor, I can create input and output streams by just wrapping it as a file. Okay, so there's a file handle to the open accessory. I create streams for it. And then just like my game with Bluetooth, once I have streams, I can just play the game the way I did before. Okay, so it's the same basic principle at that point. Okay. Let's take a look at the last one that I've got here. All right, so the last guy that I've got to show you here is my USB host demo. So in this case, what I've got is this postage scale. And using this fancy little adapter from Amazon, I am going to connect the USB host port into my tablet so that I can use it as a display for the scale. So I'm going to plug that in. Just like before, I get a similar dialog because just like with my accessory, I'm filtering for this specific device type. So when it plugs in, it says, oh, would you like to open the scale monitor app? Yes, I'd love to. Okay. So what I've got in this application is really just, it's a very basic thing where it parses out some config information from the scale initially. That's how I get the default units and the weight limit and some of that other stuff. Those are just, they're descriptors on my USB device, and I can just pull those by asking for specific report data. The scale acts like an HID device, which is the same thing as keyboards and mice. So they structure this data in reports, and I just ask for different report types. All right, so what it's displaying at any given time is just the weight on the scale. And then the color is based on whether the weight is stable or whether it's transitioning. So, you know, if I drop my phone on here, it'll show up for a second as white, and then once it's stable, it'll go back to green, right? You know, and I can take that off, and it'll go back there. So the other thing that I can do, there's a control request to 0 the scale. So I can, from a button on my screen, send that request to 0 out the scale. So if I do that, then the value will come back to 0 on the scale, and it's on the display, trust me. And then if I take this off, now the value is going to go negative, right? So if I zeroed it with the device on, then I lift it, now the color has changed to say that this is a value below 0. Those are just status bits in the report I get back to say what's the status of the scale or the status of the weight, and that's what I'm using to change this color. Okay? Then I can zero it again. It also supports part of that weight is what are the units. So on this scale, I can change the units from pounds and ounces to grams and kilograms. And so if I do that, then the value will come back in a different unit structure, and it just tells me that in the next report that I pull, so I update the display. Okay? So I didn't design this device, but it conforms to an HID spec on USB.org, so I can read the doc, figure out what the reports are, and write an app that talks to it. Okay? Yes?
How did you figure out that this postage stamp scale?
There's an advantage to using USB over Bluetooth.
Advantages to using USB over Bluetooth.
If you're designing a system.
Sure. And I think what you meant to say is that Bluetooth was a replacement for cables.
Sorry, yes.
I'm like, USB, how do you get a cable out of that? But I know what you mean. So I think at least today, the primary difference between the two is going to be speed. You know, I will every day, especially as the USB spec continues to advance, get much more throughput out of USB than Bluetooth. You know, and even as Bluetooth gets faster, so does USB. USB 3 is ridiculously fast, and we can't get anything close to that in Bluetooth right now. And I don't know that we ever will, because anytime you talk about wireless, you start getting into power considerations. So, I mean, probably the biggest thing is that just that speed requirement lets it serve different use cases. You know, an external hard drive works great over USB, probably doesn't make as much sense to do that over Bluetooth because of the throughput. But at the same time, if something needs to be portable, then a cable's kind of pointless. So I think it's just different use cases in that case. That's my thought on it anyway. Yes?
I think there are also situations where security, you plug into USB, it's pretty hard.
Harder to sniff when yes, it's more secure over a cable. That's probably true too.
Yeah, and then
Sure. So yeah, to some degree, I think it boils down to the different implementation headaches that you'd like to deal with, because they each have their own, and which ones fit better with your use case. So, yes, sir. Yes, yes. So I did mention that that's one of the things that the accessory does is rebooting the USB driver.
So does the user see like the device rebooting or something? Or is it just the driver?
No, no, it's just the driver. It's not the entire device. Good question. Yes, one more and then we're going to finish here.
So when you write that data,
Sure. So maybe after everything, maybe we can kind of, if the people who are interested in the Arduino stuff, I can kind of show you that. But really, it's packing up the raw sensor values that are coming from the analog joystick or the digital buttons, and packing them up into bytes and shipping them across. It's just a little protocol I basically invented to be able to do that. So we can take a look at that for sure. Okay. All right. So just real quick, I want to go through this example here. So just like with the manifest, in the accessory, I have a similar layout for the device, okay? So let me get this out of the way. So my activity still has an intent filter there for a USB device attachment instead of an accessory attachment, and that same metadata saying, here's how we want to filter those device connections, okay? In this case, what we're filtering for is a specific vendor ID and product ID that match up exactly with this product, okay? So, I mean, the vendor ID is basically assigned to Dymo, and the product ID is this specific model. So one thing I could do is support all Dymo scales with this app and just look for the vendor ID, assuming they're all the same protocol. I hope they do. But you can also add other values in here, like the device class, subclass, and protocol. The problem with that is, when you start looking at USB devices, you start to realize that a lot of them don't implement their class, subclass, and protocol at the device level. They implement them per interface. Think of that multifunction device where I have one physical device with 3 interfaces for 3 logical devices. The device level descriptors for those 3 values are always 0. And the individual descriptors for each interface is where they describe this is a printer, this is a scanner, this is a fax machine. I can't get the interface level stuff for filtering, only device level. So generally that one's not real useful, but technically it is there. Okay, usually the vendor and product ID are the most useful here. Okay, so by putting that filter on, then I can get that to launch my application inside of this activity. So this activity, I've just predefined a number of constants, and I ripped those right out of that HID spec. So same idea as with the accessory, where we have to request permission before we can talk to this device. But in the case where the user launched the app from that dialog, they've implicitly already granted it. So we may have a couple code paths in here. But eventually what's going to happen is we're going to end up at this same broadcast receiver that says, OK, we have an attached device. We've got permission available. Now we can start communicating with the device. Okay? So in this case, when I set the device, really that's just going in here, and this is doing some of that basic enumeration. So what I'm doing so far, I don't need permission to do, even though I checked that first. You know, I can check the interface count, I can look at different interfaces, I can check for endpoints on each interface. I can enumerate all that stuff, figure out what kind of endpoints they are, all that sort of thing. Okay? So I can do all that without having to request permission. It's as soon as I try to do open device that the permission needs to be there. Okay? So open device is going to give me one of these connection objects. And once I have a USB device connection, then I can start making requests back and forth. Now, in this example, I'm not using USB request, the asynchronous one, because like I mentioned, it's been kind of wonky lately. I'm doing this all with synchronous requests. So I mentioned the first thing that I do is update those attributes. So for the scale attributes and the scale weight limit, we just go in here, we define a report type. So these values, again, come straight out of the HID spec. Like the HID spec says that for this command, there's a command ID for getting a report, and these bits need to be set this way because of the direction of the report, the type of report it is, and its ID. All that stuff is inside the USB spec. I'm just ripping it out and using it again. Okay? So once I've constructed all those values get passed into this control transfer method that's on USB device connection. So control transfer says this command goes to endpoint 0, the control endpoint. Every device has at least one control endpoint, it's endpoint 0. Okay? So anytime you use these, that's where it's going. So I can get the data for this scale by just asking for these reports from the control endpoint. Okay? So this one is what just tells me the scale class in units. The limit data is the one that told me the maximum weight limit of the scale, so I could put that in the display. The set 0 scale was that command that I fired when I hit the button. So when I hit the button, this sends another command. In this case, it's a set report instead of a get report, with the bit flipped to say force 0 on the scale. Okay? But it's just another control transfer. And then the one that gets called regularly is this weight data. So weight data is just another report. In this case, it's report ID 3. And its length is 6 bytes. Again, I'm pulling all this stuff out of the HID spec. So we just call that control transfer again. But what I'm doing is that once set device gets fired and everything's ready to go, I'm starting a background thread to do all this polling. And the background thread is just executing the run method inside of this activity. So it's just running through and calling that update function, a few times a second. All right, so it calls the update, which does a control transfer, posts that back to the UI, which is how I update the green color and the display and the number, then pauses for a second and does it again. Just a fairly simple polling loop. Okay, and it does this as long as I consider this to be active, and then that running bit, when we leave the application, if we go to on pause, or on stop, sorry, when we go into the background, it shuts that off, which kills the thread, okay, within 25 milliseconds. So, okay. Let's go back over here. So there you go. So that's everything I've got for you. Thanks for hanging out with me tonight. I appreciate your time. As I mentioned before, the samples are on my GitHub, so that's the link there. Or you can just go to my GitHub page and you'll see it on the main page there. The beacons I mentioned are made by KS Technologies, so go to their website if you want to get more of that. Or they're going to be here Friday. If you want to look at more at our work, go to Double Encore, and then there's all my social stuff if you want to hook up with me. So, thanks again, guys.